Hello everyone, a very good morning and welcome to my course Basic Physics. This course is generally made for diploma degree students of first year, first semester. Myself, Gopal Chakraborty, Assistant Professor, Department of Physics, Greater Kolkata College of Engineering and Management, Baruipur. You can personally meet me at college premises, ground floor physics lab. You can also send me a mail regarding your query or doubt on this topic to my given mail address, that is godphysics6@gmail.com or gopal.chakraborty_gkcem@jisgroup.org. Students, I have a YouTube channel. The link is given here. So you can subscribe my channel for more videos, as I have already uploaded all the video as per your State Council syllabus on the subject Basic Physics. So if you feel any doubt, feel free to contact me at my given mail address. So for this topic, I am your subject teacher. Now the course pages are www.webscte.org and www.webscte.co.in. You can also find the syllabus is already uploaded in the university website. So the students, if you want, you can download the syllabus for first year, first semester from the State Council website as mentioned here. The title of this subject is Basic Physics. It is under the category of Basic Science course. It has a credit 3, 2 lecture per week and 2 practical per week. Now this course is generally made for diploma degree students of first year, first semester. So all the branches except architecture, photography, multimedia and printing technology, apart from these 4 departments, rest of the departments have to study this course, this subject for their first year, first semester. So as per our college, so electrical and electronics and communication, these departmental students will going to study this subject Basic Physics as a part of their curriculum for first year, first semester. Now as it is the 3rd class of Elasticity chapter, so the topic that I will going to cover in today's class, that is bulk modulus, rigidity modulus and Poisson's ratio with definition and formula, and also the relation between them, and some simple numerical problem and about Poisson's ratio. So these topics are also under unit 2, that is general properties of matter. Prerequisites for these topics are basic mathematics knowledge to solve the problem, knowledge of basic concepts science such as physics, visualization and analytical approach towards the subject is very much necessary. Now the course objectives are: analyze the bulk modulus and rigidity modulus of a material and corresponding stress and strain, and select proper material for intended purpose by studying properties of material. After completion of this topic, students will able to analyze bulk modulus, rigidity modulus of a material and corresponding stress and strain. They will also able to calculate stress, strain, bulk modulus, rigidity modulus for a given material. So these are actually considered to be as possible course outcome. So students, before start to describe the today's class topic, I would like to remind you that what are the things that we have already discussed about regarding this chapter elasticity, because this is your third class. So in first two class I have described in details about the property elasticity, plasticity, perfectly elastic body or perfectly plastic body with some example, and also we have discussed about elasticity modulus. Okay, so from there what I have already discussed that elasticity is basically a property of the material by virtue of which it actually try to resist is a change in shape or size when some deforming force is applied on it. Okay, and I have also shown you how that resisting force, that means restoring force, comes into act when you apply some deforming force from the outside. Okay, so due to that presence of that restoring force, the body or the particle try to regain its original size and shape. Okay, it may be possible in fully or partially, or in some case it may not be happen due to the plastic nature of the body. So but the perfectly elastic body is completely regain its original size and shape by this help of restoring force. So from there I have also discussed about stress and strain. These all things are actually needed, and you need to know these things because this is very much needed for this today's class. So what is strain, stress, and these things are basically stress is force per unit area. Okay, what is force? Which type of force? It is that restoring force which generate due to application of that deforming force. Okay, so that restoring force per unit area, that is called stress. So it has a unit Newton per meter square. And what is strain? Strain is the change of parameter with respect to the original parameter. If it is the length, so strain will be change in length with respect to original length. If it is a volume, so change in volume with respect to original volume. If it is area, so change in area with respect to original area. So this is your strain. So it is a unitless quantity. So from there what we have shown you that how many types of different kind of elasticity modulus is there. So I have described in details what is Young's modulus, rest 2, bulk modulus and shear modulus I will discuss today. So what is that Young's modulus? It is the ratio of longitudinal stress with the longitudinal strain. So that means force per unit area whole divided by change in length with respect to original length. So that is the your Young's modulus and denoted by Y. So these all elasticity modulus actually depend on the properties of the material. So it will not depend on the other physical property. That means if you change temperature, you can also change the pressure, you can also change the force, applied force. According to that your change in length will also change, or change in volume will also vary, but your that ratio of stress by strain, that will be always constant. If you change the material only, then only it will change, because elasticity modulus is depend on only on the properties of material. So as today I am going to discuss about bulk modulus, and second one is shear modulus. So these two also as a one type of elasticity modulus. That's why this will also depend on the properties of material, and it will change only if you change the material. So now I will discuss you and show you what is your bulk modulus, what is your shear modulus, step by step. So the students, those who have missed that previous 2 class on this topic elasticity, please go through that class or video lessons once again, because that will help you very much to understand today's class. Now the first one, that is bulk modulus. Okay, so what is bulk modulus? Bulk modulus is defined as the proportion of volumetric stress related to the volumetric strain on a specified material. So while the material deformation is within elastic limits, so this is very important. To put it more simple words, bulk modulus is nothing but a numerical constant that is used to measure and describe the elastic properties of a solid or fluid when pressure is applied to all the surface. In any case, the bulk elastic properties of a material is used to determine how much it will compress under a given amount of external pressure. So the value is denoted with the symbol of capital K, and it has the dimension of force per unit area, so it is Newton per meter square. So now, as I have already told you that as Young's modulus is related with the longitudinal stress by longitudinal strain, so here bulk modulus is simply the ratio of volumetric stress by volumetric strain. That means for a solid, if you apply the deformative force 3-dimensionally from all the directions, so that volume must be changed. Okay, so it may be increased if you elasticate, if you stretch it, and it will be decreased if you apply the force in opposite direction. Okay, if you try to squeeze it. Now due to application of this force, what will be the change in volume? That will be del V with respect to original volume, that is, say, let us consider V. So change in volume with respect to original volume, that will give you the volumetric strain. Okay, and that force per unit area, restoring force, due to which it tried to regain its original size and shape, that force per unit area is called volumetric stress. So that stress by strain is your bulk modulus K. So as when you apply a force, it will try to decrease its volume. So here it is denoted with a negative sign, that's K equals to minus of del P. Why it is P? Because P denotes the pressure. Pressure is force per unit area is the pressure. So del P by del V by V, that is the volumetric strain. So actually F by A minus of F by A del V by V. So K is equals to minus of V into del P by del V. So this is the expression of bulk modulus. Okay, and you can also write another term is there, that is called compressibility. So 1 by K inverse of that bulk modulus is called compressibility. So it is this bulk modulus. This is also one type of elasticity modulus, and it is always remain constant, and it will change only if you change the material. Okay. So here the table is for your reference, shows some bulk modulus of some common materials that is used in daily life in practical. So here it is shown that aluminium has a bulk modulus 72 into 10 to the power 9 Newton per meter square. Brass has a bulk modulus 61 into 10 to the power 9. Copper has a bulk modulus 140 into 10 to the power 9. Glass has a bulk modulus 37 into 10 to the power 9. Iron has a bulk modulus 100 into 10 to the power 9. Nickel 260 into 10 to the power 9. Steel is 160 into 10 to the power 9. Water, it is 2.2 into 10 to the power 9. Ethanol, it is 0.9 into 10 to the power 9. carbon disulfide, that is 1.56 into 10 to the power 9. Glycerin, it is 4.76 into 10 to the power 9, and mercury is 25 into 10 to the power 9, and lastly the air at STP is 1 into 10 to the power minus 4. All the unit of this bulk modulus is Newton per meter squared. Now what is shear modulus? So rigidity modulus or shear modulus, this is basically the ratio of tangential stress with a shear strain. So if you can define it as a within elastic limit, the ratio of tangential stress to shear strain is called rigidity modulus or shear modulus. Now what is that shear strain? Say, let us consider, if you consider a book, okay, it's a solid book, okay. Now if you apply a force on the upper surface and the lower surface is kept on the table, what will happen? Due to the friction, the lower surface is still there and the upper surface is trying to move in the positive direction, positive x direction, okay. So what will happen? It will make angle, if you consider the any one side of that book, so it try to make it angle because the upper surface is moved in the forward direction but the lower surface is still there. So that angle of rotation, that change angle, that will give you the value of shear strain. So as here I have shown you a diagram. The diagram basically shows, we consider a square block, it may be rectangular also. So here the area of cross section is A, okay, and we apply a force in the upper surface. Lower surface is kept fixed there, okay. So if you keep fixed the lower surface, upper surface try to move in the positive x direction. Now what is that change in angle? Here it is shown that the change in angle is theta, okay. So you can represent theta in terms of that length, in terms of that height, okay. So that can be written as theta. Theta, from here you can write theta, that means which is very less, that's why theta equals to tan theta. So from here it is AA dash by AB, that is means del L by L. If L is the actual length, del L is the change in length, so del L by L will give you the value of theta. So the rigidity modulus you can express in terms of eta. So eta is equals to tangential stress, that is force per unit area, by shear strain, that is theta. So F by A whole divided by del L by L. So that is the expression of rigidity modulus. And as the rigidity modulus is also a elasticity modulus, so it will also it is also depend on the properties of the material only, not depends on the other physical properties, okay. So if you change only the material, then only it will change. As it is also a ratio of stress by strain, and strain doesn't has any unit, so the unit of tangential stress, that will be equals to the unit of rigidity modulus. So it has a unit in SI, Newton per meter square, or in CGS you can say it is dyne per centimeter square. Now as I have already discussed about three different elasticity modulus, that is Young's modulus, bulk modulus and rigidity modulus. Now some term is there that is very important, you need to know this, that is first one is elastic after effect. Now the bodies return to their original state on the removal of the deforming force. Some bodies return to their original state immediately after the removal of the deforming force, while some bodies take longer time to do so. The delay in regaining the original state by a body on the removal of the deforming force is called elastic after effect. So in galvanometer, suspensions made from quartz or phosphorus bronze alloy are used because their elastic after effect is small. On the contrary, glass fiber takes hours to regain its original state. So this is called elastic after effect. Next one, what is elastic fatigue and what is the importance of it? So here the picture is shown here. Here torsional pendulum is considering, which is rotate with some angle theta, so from the mean position of rest. Now in a torsional pendulum, a disc oscillates in a horizontal plane. The elastic twist of the suspension wire provides the restoring torque. During torsional vibrations, the wire is subjected to repeated alternating strain. If we set the wire into torsional vibration, it will continue vibrating for a long time before its vibration die out. If it is again made to vibrate, its vibration will die out in a lesser time. So due to continuous alternating strain, the wire is said to have been tired or fatigue. So elastic fatigue is defined as loss in the strength of material causes due to separated alternating strain to which the material is subjected. A hard wire can be broken by bending it repeatedly in opposite direction as it loses strength due to the elastic fatigue. For the same reason, the railway bridge are declared unsafe after a reasonably good period to avoid the risks of mishap. So this is your elastic fatigue. Next one, that is elastic hysteresis. So this figure shows the stress strain graph for a rubber sample when loaded and then unloaded. So for increasing load, the stress strain curve is OAB, and for decreasing load, the curve is BCO. So that means the curve didn't follow the same path when it comes back. So the fact that the stress strain curve is not retraced on reversing the strain is known as elastic hysteresis. The area under the curve OAB represents the work done per unit volume in stretching the rubber. The area under BCO represents the energy given up by rubber on unloading. So the shaded area of the hysteresis loop represents the energy lost as heat during the loading and unloading cycle. Now a very important term, that is Poisson's ratio. What is Poisson's ratio? By definition, it can be expressed as within elastic limit, the ratio of lateral strain to longitudinal strain is called Poisson's ratio. Okay, so it is denoted by sigma. So the Poisson's ratio is the ratio of lateral strain by longitudinal strain. The very interesting thing is that it is not the ratio of stress and strain, it is the ratio of strain with respect to strain. Okay, lateral strain with respect to longitudinal strain. So that means in the above and denominator, both sides, it's same kind of quantity, so it doesn't it has no unit. Okay, it is a unitless quantity and it is a constant Poisson's ratio. So as it is the ratio of strain, lateral strain with longitudinal strain, and as it is not the ratio of stress by strain, so it is not the elasticity modulus? This is a very important question. In some case the question came in that way there, show or explain why Poisson's ratio is not a elasticity modulus. So this is the reason for why, as it is not the ratio of stress by strain, that's why it is not a elasticity modulus. Now how you will find out that Poisson's ratio? Suppose you consider a rod, okay, rod having length capital L and the diameter is D, or you can also consider some wear, and you know if you stress the wear, its length increases but its diameter decreases, isn't it? So so this change in diameter, that is your lateral strain, and the change in length with respect to the original length, that is longitudinal strain. So you can easily find out that as here I am considering that capital D is the diameter, so the lateral strain is del D by D and the longitudinal strain is del L by L. So the Poisson's ratio can be written as, it is also in a minus sign, because if you increase the one, other will simultaneously decrease. If you increase the length, the diameter will decrease. So that's why it is negative. So sigma is equals to minus of del D by D whole divided by del L by L. So this is the expression of Poisson's ratio, and it is confirmed that Poisson's ratio is not elasticity modulus. Okay. So it has no unit, it has no dimension also. So student, this is the basic theory part of the chapter elasticity. Now I will solve some problem, show you some numerical, so that you can practice those numerical, and it will be very easier for you to understand this chapter in very clear way. Now the first problem, that is the pressure of a medium is changed from 1.01 into 10 to the power 5 Pascal to 1.165 into 10 to the power 5 Pascal, and change in volume is 10%, keeping the temperature constant. Find the bulk modulus of the medium. So how can you find it? So you know what is the change in pressure, that is P is equals to 1.165 into 10 to the power 5 minus 1.01 into 10 to the power 5. Ultimately you will get 0.155 into 10 to the power 5 Pascal. And so this is your stress, volumetric stress. And what is this volumetric strain? That is LV by V, that's equals to 10%, that means 0.1. So your bulk modulus, as you know, it is the volumetric stress by volumetric strain. So simply put the value, give you K is equals to 1.55 into 10 to the power 5 Pascal. Next problem, the average depth of Indian Ocean is about 3000 meter. Calculate the fractional compression del V by V of the water at the bottom of the ocean, given that the bulk modulus of water is 2.2 into 10 to the power 9 Newton per meter square. So bulk modulus is given here, and you are asked to find out del V by V, the fractional compression. Now stress is equals to pressure exerted by the water column of height 3000 meter. So that pressure is equals to, you know, P equals to H rho G for a water having a depth H. So H rho G, that means 3000 into 100 kg per meter cube into 10 meter per second square. So that will give you the pressure is 3 into 10 to the power 7 Newton per meter square. Now as the bulk modulus is volumetric stress by volumetric strain, so the value of volumetric strain or fractional compression, that is equals to stress by bulk modulus K, so it's equals to 3 into 10 to the power 7 by 2.2 into 10 to the power 9. So ultimately what we will get, it value del V by V is equals to 1.36 into 10 to the power minus 2, or 1.36%. Here another problem, a rubber block 1 centimeter into 3 centimeter into 10 centimeter is clamped at one end with its 10 centimeter side vertical. Horizontal force of 10 Newton is applied to the free surface. What is the horizontal displacement of the top face? A modulus of rigidity is given of rubber is 1.4 into 10 to the power 5 Newton per meter square. So area is given, that is 1 centimeter into 3 centimeter, that means 3 into 10 to the power minus 4 meter square. Force is 30 Newton. The rigidity modulus that is given, eta equals to 1.4 into 10 to the power 5 Newton per meter square, and the length is 10 centimeter, that means 0.10 meter. So as you know, eta, that rigidity modulus, that's equals to F by A whole divided by del L by L. So from there you can write del L equals to change in length, that's equals to F by A into L by eta. So now if you substitute all the value, you will get 0.0714 meter or 7.14 centimeter. So that's our answer. Another problem, that is a 60 kg motor rests on 4-cylinder rubber block. Each cylinder has a height of 3 cm and a cross-sectional area of 15 cm square. The shear modulus for this rubber is 2 into 10 to the power 6 Newton per meter square. If a sideways force of 300 Newton is applied to the motor, so how far it will move sideways? So it is the same kind of problem as I have solved in the last one. So here also, if that force is given, that is 1/4 into 300, that is 75 Newton. L is 3 into 10 to the power minus 2 meter. Area of cross section is 15 into 10 to the power minus 4 meter square. Eta is 2 into 10 to the power 6 Newton per meter square. So from there, from the expression of rigidity modulus, you can write del L equals to F by A whole into L by eta. So substituting all value will give you 7.5 into 10 to the power minus 4 meter. So it will move in sideways is 0.075 centimeter. Now another numerical, that is determine the Poisson's ratio of material of a wire whose volume remain constant under a external normal stress. So volume of the wire, that is equals to pi d square by 4. As you know, the volume is pi r square h. So here d is the diameter, pi d square by 4 into L. L is the length. So as volume the remain constant, so differentiating of the above equation gives 0 equals to pi L by 4, 2 into capital D, D of capital D, pi d square by 4 into dl. So you can rearrange and you can write d of capital D by D is equals to minus of half dl by L. So as you know, Poisson's ratio is the ratio of lateral strength with longitudinal strength. So it gives us sigma value, that's equals to minus, so minus will cancel out and give half of dl by L whole dl by L. So that's equals to half, that means 0.5. These are the books that you can refer. The evaluation process is same. You have to appear for a 70 marks end semester exam and 20 marks mid semester exam. Assignment and attendance also consisting of 10 marks. So with this today's video lesson, I have completed the chapter elasticity. So hope all of you have understand and enjoyed this class. In next day I will start surface tension. So thank you.